The last time we were together, we talked about how matter comes in three different states, and the time before that, we talked about how all matter has mass and takes up space. So today we're going to take the ideas of the has mass and takes up space, and we're going to expand on that to a concept called density. So first, let's start with the concept of mass. Mass is how much stuff there is in an object. And we are going to measure that. In the metric system, we're going to use grams. Now, you could also use kilograms, you could use milligrams, you could use any form of a gram. I just put grams because that's the standard unit that we normally use. But again, you could use kilograms or milligrams or decigrams or whatever type of gram you wanted to use. I do want to remind you that mass is not the same thing as weight. If you step on a scale and you say, oh, well, I weigh this many pounds, that's measuring your weight, and it is not the same thing as mass. Weight has to do with how much gravity is pulling on you. And so if we actually talked about this in chapter 17, if you recall. And so if you go to the moon, the amount of stuff, the amount of matter in you doesn't change. But if you take the scale and weigh yourself here, and then you weigh yourself on the moon, you're going to find you weigh a lot less on the moon because the pull of gravity on the moon is much less. So just keep in mind that mass and weight are not the same thing. But mass is defined as the amount of stuff that's in an object, and weight is the amount of pull that gravity has on that object. And it does depend on your location, okay? So mass is something that you're going to measure on a scale or on a balance. Then the other characteristic is volume. Now, in your math classes, I am sure that you have learned to calculate volume of all sorts of things. If you have some sort of a rectangular solid, you've learned that the length times the width times the height is going to be volume. Okay, so that probably should look very familiar. If you have a cylinder, like a can, you've probably also learned there that if you want to find the volume of that, you're going to take pi times the radius squared times the height. And so all sorts of different ways to measure volume. The units for volume are either going to be in cubic centimeters or in milliliters. Now, this is how we're going to measure the volume of something that's regular. But how about if I'm trying to find the volume of something that's not regular? Let's say, for example, maybe I want to find the volume of this measuring spoon. Maybe I want to calculate the density of it, which we're going to get to in just a second here. But how would I find the volume of this? There's no way for me to measure this and figure out what the volume of it is. Well, there's a way to measure volume by displacement. And you're not going to be doing this in a lab or anything because I've not required my physical science students to have graduated cylinders, but I want to show you the process because on the density worksheet that I have for you in a day or two, you're going to be working some problems where you're going to use this idea. This is a graduated cylinder, and we use it in chemistry. So if you take chemistry when you get into high school, you will use one of these. We use this to measure liquids pretty accurately. And I just have water in this, but I put a little bit of food coloring in it just so that you would be able to see it better on the video, so that it would show up a little bit better. So there are markings on the side of this cylinder, and if you take chemistry with me, I'll teach you how to read a graduated cylinder. But for right now, I'm just going to read it so that so that we can get the concept down here. Right now, if I read the amount of liquid that's in this graduated cylinder, I get a volume of 39.8 milliliters inside this graduated cylinder. So if I take this spoon and I drop it in here, now if you watch, you're going to be able to see that the volume level is going to go up. It didn't go up a whole lot, but it did go up a little, and so if I read it now I have a volume of 41.1 milliliters. So if I take 41.1 milliliters and I subtract my initial volume of 39.8 milliliters, that's going to give me 1.3 milliliters. So the volume of my spoon is 1.3 milliliters. which is the same thing as 1.3 cubic centimeters, because a milliliter and a cubic centimeter are the same thing. Again, that's not something I expect you to know right now. We'll hit a lot more of that in chemistry. But what you can do to measure volume of something that's got an odd shape is by displacing water with it. So you take the initial volume that you had and the final volume that you had, you subtract them, and that's going to give you the volume of the object that you then dropped in the water. This was a technique that was actually used by, I'm trying to remember what the guy's name was. I want to say Archimedes. The king thought that the guy who made his crown for him, he was supposed to make it out of pure gold, the king thought he got cheated. And so he wanted to find out if there was a way to figure out if this crown was made of pure gold or not. And so what they did is they took the gold crown, or what was supposedly the gold crown, and they dropped it down in the water to measure the volume of it by displacement, like I just did with that spoon. Then they put it on a scale and they measured the mass of it, and then they calculated the density. So what's density? Density is mass per unit volume, and so how many grams are there per milliliter or per cubic centimeter of that particular object. And each substance has its own particular density. And since Archimedes knew what the density of gold was, he could calculate the density of this crown and find out if the king got cheated. And as it turned out, the king did get cheated. It wasn't pure gold. And so Archimedes was able to figure out, by using the mass and the volume that he measured by displacement, he was able to figure out that the guy who made the crown had definitely cheated the king. So density, again, you're going to just take the mass that you measure and you're going to divide that by the volume. And I'm going to do a couple of examples for you here in just a second. If you have not had a lot of algebra yet, you can take this equation and you can rearrange it, because sometimes maybe you know the density and you want to find the volume. Or maybe you know something else and you want to be able to find the mass. So you can take this equation and you can rearrange it. So what I would recommend that you do is take an index card, like we've done for so many of the chapters in physics, and write down all three of these equations on it. If you want to find density, you're going to use this one. If you want to find mass, you're going to multiply the density and the volume times each other. And if you want to find volume, you're going to take the mass and divide it by the density. So write down all three of those so that you have them. Excuse me. And we'll work a couple of examples here so that you can see how this works. Okay, a piece of aluminum has a mass of 10.2 grams and a volume of 3.8 cubic centimeters. What is its density? So since I'm trying to find density, I'm going to use D equals M over V. So I use that equation. It tells me that the mass is 10.2 grams, and I was told that the volume is 3.8 cubic centimeters. And again, sometimes your volume is going to be in milliliters. Either one works, either one's okay. And so if you take your calculator and you take 10.2 divided by 3.8, you're going to come up with an answer of 2.7. And the units for density are grams divided by cubic centimeters in this particular case, because that's what my units were. So units for density are always the mass on the top and the volume on the bottom. Okay, so let's do another example that uses density, but that's not what I'm trying to find. So let's look at this one. A piece of gold has a mass of 25.2 grams and a density of 19.3 grams per cubic centimeter. How much volume will it occupy? Well, if I look over here at my equations, this is the one I use if I'm going to try to find volume. Volume equals mass divided by density. And so the mass is 25.2 grams and the density is 19.3 grams per cubic centimeter. And you can see here that I have grams on the top and I have grams on the bottom. And so those two units will cancel each other out. And so if I take 25.2 divided by 19.3, I'm going to come up with 1.3. What units is that going to be? Well, it's the unit that I have left over here. So it's going to be 1.3 cubic centimeters. right? So over the next couple of days, you guys are going to get quite a bit of practice doing all kinds of density problems.